All right. So, we were supposed to finish Game of War. Is that it? How'd that go? Easy?
Easy.
Only 3 hours?
Only like 5.
Oh, that's weak sauce. I just learned that word. Is that a word? Somebody messed. Oh, there we go. No wonder I've been all off kilter the last couple of days. Somebody messed with us. Must have had a short person sitting here.
I don't like those people.
I know, seriously. I know who it was, too. It was Nick Largent. Do you know Nick Largent?
Don't.
A little short dude. Oh, my gosh. Can't stand them. He's working on my boat right now, actually. That comes in handy, being little, because he can get into all those little spots. I cannot, from like all sorts of reasons. Well, hold on. Was there a question I was supposed to be answering? Or what happened? Oh, 3 hours. Now I know. 3 hours. Okay, yeah. So 3 hours is that's pretty good. That's dedication to homework. But I really like when the 300 students, the 2 classes from here, when they spend like 8, 9, 10 hours on their homework, and then come in like because they haven't slept in a day. I had a student the other day from that class tell me it was the hardest class they've ever taken in their life. I was proud, so proud. I just love this job.
Love torturing students.
Well, it makes them better. That same guy who said that's probably in the top 3 programmers in our department. Because he put in those 10-hour days for assignments and stuff instead of just saying, oh, this is too hard. Screw it. Okay. So let's see. Where did we leave off? I think we put everything inside main, right? Okay. So we get our actual values. Fill up our deck. Deal to our players. And then we proved each player had kind of the right number of cards. Okay, so now we need to play Game of War. PlayWar right here. So PlayWar is going to take in 2 players and the deck that they're going to be operating on. I think I saw something on Slack. Did you actually need the deck here?
No.
Probably not, because the players already have their cards dealt to them. Realistically speaking, I think what I was thinking about is something along the lines of... Jeez. Almost there. Is actually dealing the cards inside of PlayWar. Doesn't matter. All the same crap. But I think maybe that's what I had in mind. Which means I don't need to call it here, and I don't need these guys. So I set up my 2 players, and then I'm going to call PlayWar, passing it my 2 players. Player 1. Player 2. And the deck. All right. And then this guy is going to do all the work up here. So PlayWar, we'll start off by dealing the cards, and now P1 and P2 should both have, actually, I'm not passing it Player 1, Player 2, I'm passing it P1 and P2, and the deck. So when this is said and done, P1 and P2 should have their cards dealt to them. Now we want to just keep going back and forth, back and forth, back and forth until one of the players runs out of cards. Right? Okay. So let's create a loop for that. So we want to repeat until. We could have done while as well. Repeat until I need logic, not math. I want to get the length of player one's deck, which is his thing at position 2. Right? So list length of in list, which is our player. What list? P1 get position 2. So we want to keep going until that guy has a length of 0 or the other dude has a length of 0. So more logic. So either P1's hand has a length of 0, or P2's hand has a length of 0. Okay, go ahead.
What if you just said until list P1 in or P2 are empty? Would that work? Or?
Well, P1 and P2 are players. So that means not only are they out of cards, but you're actually killing off the player. You're ripping their name away from them, and the second list, which I know some people didn't use, they just used the one deck, right? Whatever, didn't matter. Yeah, but really, you know, if I'm a player and I have a deck, I have a hand, I guess we'd really call it, right? And that's my list at position 2. As soon as I run out of cards, I can no longer play war. That's when this guy should stop. Okay, so it should be impossible, given the nature of this game, for them both to run out of cards at the same time. Right? Somebody's winning. All right, so we're going to keep doing something over and over and over again as long as both guys still have cards. That's what this says. Okay, if either of them have no cards, then we're going to stop. And what are we going to do each time? We are going to play a hand. Or play, but we're going to, yeah, I guess call it play a hand. Sounds reasonable. All right, so I need another function.
I know, I saw you coming up.
Call this play hand. Play hand should take in a P1 and a P2. Needs both of our players to play their hand. All right, and so initially what we're going to do is we're going to get the 2 cards associated with, so each player is going to take a card off their, that we're going to compare those, right? All right, so we're going to create a couple of variables. Set. Oh man. Do I have too many variables? I can't even rename it. Ha-ha! We're limited to about 3 or 4 more variables. No more. Okay, so this guy, we're going to rename this. We're going to name this one P1 card. And we're going to have another one of these guys. This guy's a new variable, P2 card. And we're going to go ahead and grab a card from the top of this guy's, each of their decks. You didn't have to store it in a variable, but I think it's going to be a little easier for us. All right, so I'm going to say we need to get the top card from P1's deck. So that is in list. Oh, that's not what I want. In list get. What list? P1. Get bucket 1, 2. Get bucket 2. That's his cards, right? All right. Now that's a list. And now I want to get the first element from that list. Get and remove. So, is that still this guy? Get and remove first element. So that'll be P1's first card. Then I want to get P2's first card. So now I have two cards. And we just happen to have a function called compare cards that I could pass two cards to. So I'm going to call that function. Oh, I got to set it to a variable. So close. Set answer equal to compare cards, passing it P1 card and P2 card. Here's P1 card, and here's P2 card. And this guy is going to give us an answer back. The answer is going to be either first, that's if P1 card won, second, that's if P2 card won, or third, that's if, or tie rather, if they were the same. Okay, so now we want to ask a question. Throw some logic in here. If answer is equivalent to first, that means that P1 won, correct? So we're going to put P1 card and P2 card both into P1's winning deck. That was my intention. I know some of you use the bigger deck thing. So then what I'll say is I'm going to say list first we need to get the list. And list P1, that's this guy. Insert at, doesn't matter if we say last or first. So we're going to insert at to the end of that list P1 card. As well as P2 card. All right, that's if the first guy won. Else if the second dude won, I need to drop this to P2 card, right? The second dude won, we're going to add him to P2's cards. Else we have to go to war, right? So either the first guy won and he gets both cards, the second guy won and he gets both cards, or we're going to war. And what's war? War is burn 3 cards and then compare the last one. Okay. So I'm going to create a function. Actually, I think we can probably just do it. All right, we'll just do it in here. It's going to be messy either way. So we're going to go to war, and war says do what? We're going to have a loop. Well, first, we're going to create a list. And we are going to create a new variable. Row. New variable. Can we still see it okay? Still visible? All right. New variable name. We're going to call this the pot. Because they're all fighting for that. And that's going to be the empty list. Then we're going to create a little loop. And we're going to try to do something 3 times. And what are we going to do those 3 times? We are going to grab a card from player 1's list, which is what we did shouldn't these be 3? Because we're adding it to their winning list, right? I know you guys added it to the end of your deck, but I was adding it to my winning list. So I guess either one of those worked, but just to stick with my logic. So in this case, last. So we're going to get 3 of P1's cards, and we're going to add them to the pot. List. In list. The pot. Insert at last this card. So we'll grab 3 of player 1's cards, and we're going to have to ultimately add a little if statement to here, make sure they didn't run out of cards. If they run out of cards, they automatically lose. Okay? So we'll deal with that here in a second. Similarly, we're going to grab 3 of player 2's cards. All right, so player 1 peeled off 3 cards, put it in the pot. Player 2 peeled off 3 cards, put it in the pot. So now the pot now has 6 cards in it, right? Now we got to go compare the last cards. So I'm going to actually steal these guys here. P2 card is player 2. And then we'll get our answer. Okay. And then we need to do the same logic here again. So, what do we do when we have some code that we need to repeat more than one time, giving it different inputs? Put that into a function, right? So I really need to take the test, who won, and put it into a function. So I'm going to create a function. And this function is going to, this is going to be a really fun one. Actually, you know what? We're going to do this. We actually already have the function. We're going to get rid of this. We're going to get rid of this. And we're going to get rid of that. So we took 2 cards, we played. If one of them won, we set it. If another one won, we gave them their cards. Otherwise, we started filling cards into the pot. Then we called then we're going to call play hand again, passing it player 1 and player 2, and let them play 2 new cards. Because those guys might go to war again, right? So I'm actually going to do this. Function, play hand, passing it P1 and P2. Because isn't that what we're doing right now? After we burn 3 cards each, aren't we just playing another hand? True?
True.
Okay, we're just playing another hand. Okay, now an issue we have here is when we play that hand, this all is going to go down, and somebody's going to eventually win, or we're going to play another hand for war, correct? But in the end, when we come back out here, when we finish play hand here, aren't we going to have to know who won? So we know who to give the pot to? We have to know who ultimately won. So what I'm going to do is, let's do it this way. We'll change that here in a second. And P1, P2. And then we're going to take all of this crap. We're going to throw it in here. Then we get rid of this and rename this player hand. So all we did is we changed our player hand to actually be a function that returns a value. So it grabs two cards, compares them, determines who won. If neither of them won, it goes to war. And what happens when you go to war? You ultimately, I'm going to actually reuse our variable called answer. We'll set answer equal to whatever's returned by our function, play hand, passing it P1, P2. All right. Then ultimately we need to test answer to decide who gets the pot. Correct? But up here, we need to make sure we're ultimately returning an answer. So if this guy won, here at the end, actually, hold on a second. Do I have the ability to just return something? Is that in here? Can I? Oh, should be fine. We'll just return answer. So at the end of this function, we're just going to return answer. So if the first person won, we'll not do the else if, we'll not do the else, we'll return answer, it'll return first. If the second person won, we'll return second. If there was a tie, we'll ultimately return tie, but not until after we've already gotten our answer. Okay? So inside this else, we're going to ask a question related to answer. Who won, first or second? It can only be one of those two. Correct? It might go to war multiple times, but eventually somebody's going to win. Okay, and that's what's ultimately going to get returned here. All right. So we'll ask a question. If answer is equal to first, this is after going to war, then we're going to take our players, list 3. Well, let's see, let's look at lists real quick. Create list. We're going to create a list with our players list 3 and the pot. And we want to store the result back in our players list 3. So we're going to say in P1, set bucket 3 equal to the list created with player 1's list 3 and the pot. Else, player 2 must have won. Therefore, will give the pot to player 2. Okay? So one of those two dudes will get the pot. Now, eventually, we need to have a winner. Okay? When do we finally have a winner? When somebody's out of cards. Play hand is going to keep running every single time we call it, but also until somebody actually runs out of cards. Because we're calling it from PlayWar. So PlayWar will deal the cards to both players, then repeat until one of the players runs out of cards. What's it going to repeat? It's going to call play hand. All right, and play hand ultimately is going to return who's the winner. So we're actually going to set PlayWar. Go ahead.
Don't we need to print the answer as well? Or?
We don't need to print the answer. We ultimately want to print who the winner is. We don't necessarily need to know each time the hand was played whether first or second one. What we ultimately want to know is who won the game. Right? Okay, so as long as at least one of the guys still has cards. Well, no. As long as both of the guys still have cards, we're going to keep playing the game. All right? And what does it mean to play the game? It means play a hand, and we're going to pass that P1, P2. So we'll play a hand. Play a hand means go up here and do this crap. So we'll grab a card. We'll grab a card from each player. Compare those cards to find out who won between those two cards. We'll either get a first, a second, or a tie. If we get a first, we give the list.
Let's see.
See. Insert at last list 3. Oh. It should be okay. This is in list P1, get 3. We'll give them both cards. Okay, so if that guy wins, he gets both cards. If the second guy wins, he gets both cards. Otherwise, we have a tie, and therefore we're going to war. So we create a brand new list for the pot. We burn off 3 cards from the first guy, right? Then we burn off 3 cards from the second guy. But what if we run into a situation where one of these guys doesn't have 3 cards? Yeah, if they're out of cards, they lose. What about the scenario, let's just assume we're really playing the game. And actually, could this ever happen? Could one person, I don't think it can. We can't have both people not able to have 3 cards. We can have one dude who only has 2 cards left, but then the other guy has just a giant stack of cards, right? Okay, so we shouldn't have a situation where one of these guys, where both of these guys would lose. So what I'm going to do is I'm going to create a quick little variable here. We're going to set this guy, new variable is winner. And we're going to start it off equal to nobody. But then we need to ask a question, logic. If actually, we could probably just do it right before this, can't we? So actually, I don't even need the is winner. I could just ask the question beforehand. We could say if we want to say, can they afford to play war? So they need to have a minimum of 4 cards to afford to play war, right? So if, let's see, this is player 1's get bucket 2. So we're going to need that guy, and we want the length of that guy. So list length of him. So if the list is less than 4, then we can print player 2 wins. Else if we're also going to have an else. If player 2 doesn't have at least 4 cards, then we're going to say player 1 wins. Else, we know they both have enough cards, therefore, we'll go ahead and go to war. Make sense? All right, now eventually, we're going to, that's in play hand. So eventually in play war, where are we at? Play war, we're looping. Eventually one of these guys runs out of cards and we fall out of this thing. That's if we haven't already screamed that there was a winner. Correct? So then what are we going to do? Pretty similar if statement. We're really asking who has no cards left. I'm actually just going to steal this. And then we should be done. And then we'll review. Here's play war. Okay, so as soon as this loop is over, if player 1's out of cards, then we'll print player 2 wins. Else, print player 1 wins. All right. We may have said that already beforehand, but as it's written right now, we actually are stuck in a slight infinite loop. And the infinite loop deals with, in our if statement here, if they don't have 4 cards, we're printing out the winner here, but what we need to do is we need to go ahead and empty out their cards. So in here, we're not actually burning their cards. So if player 1 doesn't have at least 4 cards, they probably have at least a couple of cards, right? Before we declare there's a winner, in fact, we can actually avoid printing here and avoid printing here and then rely on it printing in the other place as long as we empty their deck. So what we'll say is List. We'll do this. This is player 1's that's their deck. We want that deck to have nothing in it. So what we'll do is we're going to set list P1 at position 1, at position 2 rather, equal to the empty list. And that's what we'll do if P1 loses. Otherwise, if P2 loses, we'll empty P2's deck. Which means that the next time we come through our loop down here, let's deal cards, PlayWar. Next time we come through this guy, one of our two guys will have no cards in their deck, and we'll declare who's empty. Make sense? All right. So this is at least, it comes pretty close to working. We might have a little bug in there, but I want to go through the slides real quick just to tell you. So of course you'll have to write this by hand on the final.
XML, right?
Yeah, correct. You won't have access to Blockly, so you'll have to do the XML version of it. I mean, I thought that was kind of given, right? Exactly. CSC200. All right. So quickly, I'll flip through this. I'm just going to give you an idea on what things I will likely put on the exam if I were writing it today. Okay. Certainly, these are things. This is stuff. It is cumulative, so it's from the beginning of the semester. You'll have the full 2 hours to take it. I'll design the exam to take about an hour. Okay, so should not be a time constraint type problem, but take your time. Certainly a lot of our early stuff, problem solving, how do humans do it, important. How do computer programming languages do it? What is a programming language? How does the CPU work in terms of those magic tricks? The 3 kinds of languages. So all this basic stuff I think is pretty important, and there's bound to be a couple of questions dealing with it, maybe more than a couple. Okay, interpreted versus compiled languages, functional, procedural, and object-oriented, specifically procedural and object-oriented. Understand that telephone example. Probably nothing between domain-specific and general purpose. History of programming languages, kind of understand the evolution of how we got to where we are today. Probably won't ask anything about Java platform independence. Could ask you what a compiler is. Won't ask you about C# specifically and how it compares to Java. Could ask the difference between loosely typed and strongly typed and how that relates to variables. What is a variable obviously is important. There's bound to be at least one number conversion thing on there, whether it's converting binary to decimal, decimal to binary, octal to binary. I kind of like those kind of questions. Octal to binary, where you have to convert octal to decimal, then decimal to binary. Get it? Okay, so heads up on that one. So understand the conversion between bits and bytes. So I might ask you, 321 megabytes is how many bits? For example, be a fair. I tend to like those conversion type questions. Probably not ASCII Unicode. I might ask you about the Y2K thing. As opposed to anything specific about primitive types, I wouldn't ask you to regurgitate the 2.1 billion thing. Okay, let's see. How web servers work in terms of a web browser understanding HTML and JavaScript, and the web server serving HTML and JavaScript, and certain files that are non-HTML files, like PHP files, they have to get processed and then send back ultimately HTML and JavaScript. So kind of this slide and how we got to where we are, this is kind of the evolution of web languages that we've talked about since the midterm. Probably won't ask anything about centralized versus distributed. Probably nothing specific about Ruby on Rails. Probably nothing there. Might ask you something different between front end and back end, as it relates to web programming. Cross-platform tools, I might ask you pros and cons and stuff like that versus writing native versus writing a cross-platform tool. XML versus JSON for data representation. Probably won't ask you anything specific about Android or iPhone. Certainly kind of information about Blockly, kind of what is Blockly. It uses XML as a data representation language and converts to real programming languages. Okay, concept of methods, functions as it relates to Blockly. More conversion stuff. How arrays work in terms of contiguous memory. We talked about this in terms of lists in Blockly. Okay, and I would say probably the last thing is I may put a Blockly program on the test, show you the blocks, and ask you to tell me what it does. I might even put a couple of those on there. So be able to read a Blockly program. Okay? I won't ask you to write Blockly on the test because that would just be inconvenient. Except for, of course, the XML question, where I expect it to at least be 300 lines long.
And that's what, 50%, right?
80. 80. Figure 3 points. More than likely what I'll do is I'll create probably a smaller Blockly example, more of a simple one, and say, what does this do? And then maybe a little bit more complex one and ask you, what does this do? And those will kind of be the programming questions. Make sense? All right, so no programming specifically on the exam because you've done a lot of that over the last couple weeks. All right, I will see you when I see you.
Thank you again for helping us yesterday.
Oh, my pleasure. Did it work out?